Hi there, my name is John Frensley and I teach math and physics. There's so much math you can do with a golf ball and a yardstick. It's not even funny, okay? So let me tell you some things that you can do math with just a golf ball and a yardstick, both of which you can get plenty of so that each student can have them. But warning, a lot of our math classes, at least at the high schools I've recently been to, are carpeted. You have to be on a hard surface in order to do this. And sometimes the tabletop, if it's a hard surface, isn't good enough. You may need tile. Okay, so what's one thing that we could do with a golf ball and a meter stick? One thing we could do is we could have the student hold the golf ball as high above their head as they can and then drop the golf ball. And then what we're going to do is we're going to measure how high up it bounces to. Now, let's measure that several times, right? Let's measure it over and over and over again. So we're going to drop the ball from the highest height that we can, and we're going to measure the ball that it bounces up to, the height, over and over again. Then maybe we can learn about mean and median and mode and range from that set of numbers. Shouldn't it be the exact same number every single time? But it won't be. It'll be a little different. So maybe we can take 5 to 10 measurements and then see what we get from that, right? You can also do this by just having the student throw dice, right? So, okay, here's what we're going to do. You're going to throw 2 dice, 3 dice, 4 dice, and then you're going to write down 10 or 20, and you can learn about mean, median, mode, and range from that, right? Okay, here's another thing you can do. Another thing that students can do is that they can drop the ball from different heights, initial heights, I'm going to call them X, and the ball is going to fall and bounce up to a new height, which I'm going to call Y. So then what they do is they have their table of drop heights and bounce heights, and then they make a graph of Y versus X. Guess what you're going to get? You're going to get a line that leads to the origin. So this is a basic Y equals slope X or a direct proportionality, whatever it is you're teaching that involves a line to the origin, right? So then what I'm going to do is I'm going to say, okay, so now that you've got this line and you have a number for this, now what I'm going to say is, okay, how high do I have to drop the ball so that it bounces up to 40 inches or 100 centimeters or whatever it is, right? So in other words, I give them a Y that is beyond their last data point and usually off of the graph grid that I gave them. And they have to predict what the X is simply using this equation. So the challenge is to take data to form this graph and this line in order to then, when they're ready and they've got this graph and this number right here, whatever it is. For me, by the way, I'm just going to tell you my golf balls, the slope usually comes in at 0.7, meaning that the graph, that the ball reaches 70% of its drop height. Oh, there's another thing you can teach with these things is percents. What percent did the ball rise back up to from the drop height? What fraction did it rise up to, right? Does that make sense? So that's something else you could teach that's more at a junior high level. But more at an Algebra 1 level, they'll make this graph. They'll get whatever the slope is. They can do like a linear regression if you teach that, or they can calculate the slope by hand. But then what I'm going to say is I'm going to say, okay, I need this to bounce up to 100 centimeters. Where are you going to drop it? And so I'll just put my hand at 100 centimeters. They're going to measure where they drop it from, and I'm going to see how close the ball gets to my hand when it stops, right? Very easy linear equations, right? Okay, now, what else can you do? Maybe you can teach some quadratics, right? Teaching quadratics is really easy. All you have to do is have the student, that's supposed to be their head right there, okay? Yeah, let's let this be the ball. I'm not a very good artist. Can you tell? My stick figures aren't even very good. So then they're just going to kind of throw the ball. It's going to bounce, it's going to bounce, it's going to bounce, it's going to bounce, right? Like that. So my students will video this, and what they'll have is they'll have a yardstick or a meter stick in the video sitting somewhere that's right where the golf ball is. And so then I use an app called Physic, Fizziq. And what the Physic does is it will take the video. You will draw on the video how long this is, and you will say to the video, here's how long this is. This is 36 inches, or this is 1 meter, or 100 centimeters, or whatever you choose for it to be. And then you go frame by frame. So I might make the students skip to this frame, and then they're gonna tell the X and Y. Then they're gonna look at this frame, and the app tells you the X and the Y of these. All you have to do is specify a scale and specify an origin. So now what do I have? Now I've got a parabola, and I can have the students like make an equation for the parabola and things like that. Then later on, when the students learn about piecewise functions, this is more algebra 2 precalculus. Then what am I going to have the students do? I'm going to have them do all three parabolas. So we'll revisit this activity, and they'll do all three parabolas like that. And they have to make a piecewise function, three pieces, that exactly models this set of parabolas. So that's only a smattering of things that you can do with a golf ball. I haven't even gotten into things like letting the ball bounce over and over again and then just seeing the height it bounces up to. That's an exponential decay. So I can teach exponentials with that. Also, I can have the students figure out the amount of time, and then each time it bounces, that time is multiplied by the same number. It's not 0.7. It's not linear like that. But I have some physics background, and so I do the physics for the students. I just say, okay, use this formula, and based on this formula, just going to plug in. It tells you the common ratio between this time and the next time, the common ratio between this time and this time and this time and this time. And this time. Then I have them do an infinite series, and they evaluate. It's just a geometric series, and the question is, how much time does it take the golf ball to stop bouncing from the first moment it bounced? So then what they do is they'll drop the ball from the ceiling. They did all these measurements and calculations, and I will time from the first moment it hits the ground to the last time I hear any bouncing. And then we see whether or not their infinite series was correct. Usually the number is about 15 to 20 seconds, and the students get within 1 or 2 seconds of it, right? So much stuff you can do with the golf ball and with other things too. Soda bottles, a pencil and a ruler and some coins, a rubber band and a little cheap metal bucket that you can buy from Dollar Tree. So much math you can do hands-on. So if these are things you like, if you want to make your math class a hands-on class, then stay tuned to this video, and I'll tell you about a workshop I'm running that I would love for you to be a part of. Well, if you like this activity, I am wondering if you knew this. You can use things like a golf ball to teach ratio, average, linear equations, things all the way up through geometry, piecewise function, parametric equations, all the way up through infinite series and calculus. Do you know that you could use a soda bottle to teach things as simple as functional dependence at the junior high level, all the way up through related rates, all the way through calculus? What if I told you that you could use a pencil, ruler, and coins in order to do things like geometric scaling or the Pythagorean theorem or linear equations? I forgot to put on here rational functions, right? That you can do ratio and proportional and reciprocal functions and sinusoidal graphs just using a straw and a tuner, or these little pop tubes, right? That you can do quadratic functions and parametric equations with a dart launcher. You can do rational functions and asymptotes, or even teach basic domain and range with a lens and a flashlight, things that you can get at Dollar Tree quite easily. That if you have a water and a thermometer, that you could do exponential decay, that you could teach things as complicated as slope fields and differential equations. These are all things that you can teach at whatever level of math you teach, using basic stuff that you can find or buy just from Dollar Tree or from really cheap places. What about games? What about math-based games, where you could go from, basic sixth grade adding up rational numbers to games where students are shooting y equals mx plus b lines at each other, or they're shooting inequalities at each other, and there's actual strategy to it, right? What about sinusoidal graph wars, that they shoot sinusoidal graphs at each other, or they punch each other out with complex numbers, or they chase each other with the Pythagorean theorem and things like that? Is this stuff that you would want to do in your math class, playing games and doing hands-on stuff? Would you want to do some performance-based assessments, right? I'm not asking you to get rid of your traditional tests, but something that's more open-ended for students, right? What about integrating little writing pieces into your application problems, right? Your word problems, where students have to write a little bit, not just solve the problem. Is that something that you think would be valuable for your students? Is that something cross-curricular that would make you a leader on your campus? What about, would you like to see some methods of remediating tests and quizzes, right? Things where students are getting not only individual feedback, but individual remediation without you having to sit down in front of every single student. Would you like to integrate some basic computer programming in your math course? If any of this is interesting to you, I think that you ought to come to my Summer Institute for Math Teachers This summer, it's July 15th to the 18th. I teach physics and math. My forte is teaching physics teachers how to make their classes more hands-on and engaging. I've started doing that for math also. Last year was our first summer institute. We had 12 participants. They all thought it was pretty neat, the things that they could do with their students. It was much more engaging and fun and things like that. So if you go to findphysics.com, click on Math 2024 Institute, then you'll see the information. Here's some information. It is in person because there's so much hands-on stuff. But we have a discounted rate if you are the venue is a hotel conference room, so you would get a discount. Your district should be paying for it, obviously, so they would get a discount. We cater lunch every single day, so we provide you with the food. We provide shuttle service to and from the airport, so you don't have to rely on an Uber. You don't have to rent a car if you don't want to. There's lots of dining and entertainment within walking distance. So if this is something that's interesting to you, visit my website. You can contact me through the contact page there, or just look at the Math 2024 Institute. You'll see pictures from last year. You'll see a session agenda and all kind of really cool stuff. And I hope to see you there because I think that you can really jazz up your math class with some cool hands-on stuff, with some games, and just with some new instructional techniques that make math really interesting and fun to be a part of.